Thanks everyone for coming. Thank you, Clara Merriman, for pulling together during this crazy week, taking some time and all the prep work that went into creating the presentation to talk about Pony Up, how Splunk keeps Buttercup secure and healthy. Take it away.
Yep, definitely. I'm going to apologize in advance. I haven't actually ran through my presentation, so sorry for any stumbling. It has been a crazy few weeks.
No worries. We're relaxed around here.
Okay, so let me presentation mode. I think that's this button. Okay, so I'm going to talk about my team and what we do at Splunk. My team is Splunk at Splunk. That's why it's called in the title, and how we use Splunk at Splunk. Essentially, you've seen this everywhere. It's a forward-looking statement. I really don't think I'm going to be talking about anything that involves that, but you never know if something comes up, especially in questions. So you've all seen this, I probably, anyways. But this is here. So I'm Clara Merriman. I have been a Splunk user for a while now. I was a customer for 5 years, and I've been a Splunker for about 3 years now. And I've been on the same team, the Splunk at Splunk team, the whole time I've been at Splunk. My title technically is a senior Splunk engineer. I do a lot of stuff on the Splunk admin side, as well as reports and dashboards and helping users and all of that kind of stuff. And I do have a blog post or a blog series on Splunk blogs called Clarification. And I just go through and clarify things relating to Splunk, such as search commands and best practices and whatnot. So who is Splunk at Splunk? We're the dream team. I like to joke about. We have a manager. We have a business analyst that helps us like prioritize and talk with stakeholders and whatnot. We do have one software engineer that helps us a lot with our data onboarding, which is really helpful because we do a lot of data onboarding. So we have to do a lot of custom scripts, writing TAs and whatnot for all of the different tools that our company uses. And then we do have 6 engineers for the Splunk stuff, plus other things like the CI/CD and the observability and all of that stuff. We do have one engineer position coming up. It's not open yet. It will be open soon. And then we do have 3 open positions right now for DevOps observability engineers. So we're working our way towards being into that observability DevOps space. We're really working on that this year in the next couple of quarters, especially. So we've got 3 positions open for that right now. So that's our team right now, really heavily focused on the Splunk and CI/CD stuff and data onboarding. But we're ramping up because we have 4 open positions. Well, 3 right now and 1 soon to come. And we work crazy hard, but we have fun and we all work really well together. So we do a lot of stuff. Hold on one second. There we go. So our environment is one of the biggest environments. We do use Splunk Cloud, and we're one of the largest Splunk Cloud customers. We hit the 95th to 99th percentile across the board in any metric that we measure at Splunk. So we have over 261 indexes now because we create new indexes. I don't want to say every day, but probably every week or every other week, we probably have to create a new index for something. We have 1,300, almost 1,400 forwarders. That changes. Sometimes they're decommissioned. Sometimes we add new ones. Those aren't all managed by our team. Some teams manage, obviously, their own universal forwarders. But that's how many forwarders are sending data to us. And then we ingest about 2,700 gigabytes a day. And we have, when I wrote this the other week, we had 290 source types. Obviously, those change. People are changing source type names or sending new data that we don't know about to the indexes that already exist, things like that. But when I wrote this, it was 290. So it's a really big environment, and we have a lot of buyers every once in a while that we have to put out because data goes into outage, or people are sending us data to indexes that don't exist, or things like that, right? And it's crazy. Oh, and by the way, if anyone has any questions, feel free to stop me because I talk kind of fast.
One question. So how old is your index data? So how long do you, what's your retention period? I should
that's a great question. So I actually think default Splunk Cloud, like no matter who the customer is, I think default Splunk Cloud keeps a retention of 3 years. Like I think if you just run up a Splunk Cloud environment, I could be wrong, but I'm pretty sure they just retain index data for 3 years unless you tell them otherwise. Our team, we started at that. And that's why I think that because we started, we're like just 3 years because that's default. So that was our default, for every index was a 3-year retention. But we do certain indexes, we do change retention policy. So some indexes we have 13 months, or some indexes we just have like a month because we don't need it that long. We might have a few indexes we keep around longer than 3 years, but if we do, it's very few indexes and for very specific reasons. But we actually have, I think we have a ticket in our backlog to go through our retention policy and make sure we're keeping indexes around with what we want. And even if because in our indexes.conf, we actually keep those configs we manage those configs ourselves. In Splunk Cloud, technically, you don't have to keep those configs. You can edit your indexes in the UI. You can add new indexes. You can change retention all through the UI. On our team, we like to kind of keep that stuff tracked ourselves,
version controlled,
right? So that you just like you would on prem, right? So we have our own indexes.conf app that we would upload like you would upload any other type of TA. So we have it in right now it's in Bitbucket, and so a lot of our indexes don't actually have the retention period set because they were all just ported over with what Splunk Cloud, just the default. So they don't actually have the retention set. So I think we have a ticket in there to just set the retention. And so we'll go through and say, do we really need 3 years on this, or do we want to set it down and whatever? I know that's a really long-winded answer, but
yeah. No, that's good. Yeah, we that's a lot of data ingesting per day. So
yeah, it definitely is. But yeah, we do have we actually have a lot of indexes that index really large events. We have really not a lot of sources, but there are a handful of sources. We had to up the truncation limit because they hit over 5,000 lines or whatever. And so we have really large volume events as well. And so that doesn't help.
Right.
And I mean, we've talked to customers about, is there any way we can, work on that type of stuff, but it always depends on the data and what all that is too. So
a related question. So is that 3 years or whatever is set for the index actively searchable, or using dynamic archive, if I'm getting the term correctly? Because I know when we looked at the Splunk Cloud, there were options of, okay, this much data is actively searchable. I think they default to 90 days, and then anything else goes to a cheaper option.
That's a super good question. I'm pretty sure it's all actively searchable. I would have to double check, but I am pretty sure it's all actively searchable.
Okay.
Any other questions before I move on? All right, cool. Oops, did not move. Oh, no, it did. Hold on. Let me make sure so I can move to the next one. Okay. Oh, no, it did. Sorry. Okay. So this is kind of a really high level overview of just some of the things we have going on in our environment. So we have about, sorry, hold on. I need to drink water. So we have about 35 servers that we actually manage now. And those include things that basically are kind of on-prem. Because we don't technically manage Splunk Cloud, so it shouldn't include any of the things on cloud. So like we have our syslog servers, and we have we use Docker. We have a Docker Swarm environment, and we have an Ansible host, things like that. So we do manage some servers. And then we do use Lambda functions, and we have about 6 of those right now, which is, we just started kind of looking into Lambda just maybe mid last year. I'm trying to remember exactly when. So it's really new to us. That's our software engineer is the one working through those. He's super talented. So he's the one I think that's done all of those. Like I mentioned, we do have Docker Swarm. We have, this says 103 services. I'm sure that number has changed by now. Almost everything we do goes into Docker for data forwarding. So if we're coming up with new data onboarding requests, if it's not HEC, I shouldn't even say that, because if we're doing the HEC, it's going through Docker probably. But if we're just giving someone else a HEC token, then obviously it's not going through our Docker stuff. But almost everything we do for data goes through Docker. And then we have a ton of deployment clients, just an absolute crazy amount. We do actually have 2 deployment servers that we manage. One is kind of over the internet, and the other one is corporate. So that way, if there's a forwarder that can't go through our corporate server, we have an option for them as well. And then we actually use 2 Git servers. So we do have Bitbucket and we do have GitLab, which is incredibly confusing. We're in the process of migrating from one to the other right now. It's a huge process to get everything migrated over. So, but right now we do have 2. And those repositories are constantly increasing because we're constantly having new projects come up. So I'm sure that number has changed as well. Are there any questions on this before I move forward? All right, cool. This one's pretty straightforward. So just a kind of a brief history about who or what we had and where we were before we kind of got to where we are. So I joined Splunk about 3 years ago. And when I joined, our environment was, I hate to say kind of a mess, but it was kind of a mess. We were not on Splunk Cloud. We were all on-prem. And that's, I'm not saying a thing one way or the other about it, just kind of giving a general architecture, but everything was on-prem back then. And the way it was deployed was, everything was just everywhere. And there was not really any documentation about, there was no diagrams to show us what all existed or how it was all connected or anything. So when I joined, I asked, I said, is there something I can see to show me what's here? Because I don't know, I'm new. I just want to know how to admin, what exists and stuff. And there wasn't really anything. So someone just whiteboarded a general architecture, but it obviously didn't show me everything. So the numbers here are just like a guesstimate, but they're way off. And I almost guarantee it because we didn't really have any documentation back then. Sorry, go on.
Did you get the standard task of, that's a great question, you're the new person, as you figure it out, document it?
No, this was not me. I was not the person charged with the task of like figuring it all out. Thank goodness. But we did actually decommission the entire on-prem solution this last year. So it was a big task. We migrated to cloud in like late 2018, early 2019, we migrated to cloud. And then we got pretty much everyone shifted over. But we still had a decent footprint on our on-prem environment, plural. And we had to work with stakeholders over the last couple of years to push them over to there are other Splunk environments throughout the company for various purposes. Different teams have different environments for different things. And so we had to work with stakeholders to get them to the right environments that they should actually be on, and help them migrate their content and all of this stuff. And it took us forever, but we finally decommissioned our old environment. It took forever. And I also wasn't in charge of the migration effort. That was another person on my team. Hats off to him because it was a project. But so our old environment, we had the way it basically worked was if a team needed access to something, like they came to us and they're like, hey, I have this use case for whatever. Then we were like, you know what? You don't have access to our environment yet. Here's a search head. And we gave them a whole standalone search head just for their team or their use case or whatever. So we had just tons of these standalone search heads all over the place. Because that was kind of how they did role-based access, is that no one else can get on that search head, so no one can get to that data, no one can get to their stuff. And then we did have a handful of search head clusters that for kind of the bigger use cases and the bigger projects, so to say. And those were anyways. And then we had, I say we had 27 peers on the indexer cluster. It's not exactly true. We had I think 2 indexer clusters originally. One was like a staging indexer cluster that wasn't really used for anything. And one was the production one that was actually being used. And then eventually we combined them into one indexer cluster, making up like 27 peers. So originally, like when I first got there, the indexer cluster was maybe half that 27 peers. So we had all of these environments searching, like, I don't know, like 13, 14 peers. So we had, just so many users. And then we had for the roles, there were thousands of roles created for people. This is incredibly hard to manage. And there was hardly any automation for any of these things. So if we had to update servers or configurations or anything, there wasn't really hardly anything we could do to automate, but that was done for automation. So everything was very manual, and there really it was a rough go. And like I said, nothing was really documented. So it was really tough to be like, oh, what's going on? So that's kind of where we were back then. And the migration to cloud, when we got to cloud, we knew our pain points, and we made sure we weren't going to do that when we migrated to a new environment, which was great. So kind of our current environment, this is a really terrible diagram. I'm sorry, I made it really quickly. We have a way better diagram that's much more detailed, but I didn't want to get too in the weeds for this. So essentially, we have a dev stack and a production stack. They are almost identical. The dev stack obviously has less indexers, doesn't need that many because it's just for dev. And you know what? The search heads are wrong. We just added more search heads to our search head cluster. So the number's wrong, but essentially we have a search head cluster, and then we have ES and ITSI. And then we have all of these down here. So we use I shouldn't say we use it. We do have the inputs data manager, which is a Splunk Cloud product for getting data in, essentially. And we were using those, but we've been slowly migrating all of those inputs over to Docker. And the reason we've been doing that is essentially so that we don't, or mostly so we can automate, because it's hard to automate things in Splunk Cloud currently anyways. And so we want to be able to use our playbooks to be able to push updated applications and configs for inputs and whatnot more easily than we can when we're on Splunk Cloud. So we've been migrating things off just simply for that reason. But so we do have Docker Swarm, and like I said, we have our syslog. We do use DSP, which is the data stream processor. We have a couple of inputs on that. I'm sure there's more things in there, or maybe not. I don't know. Anyways, like I said, we do have 2 deployment servers. One thing that's really a unicorn in our environment is we, as a Splunk Cloud stack, I don't think this is very common. We do peer to another Splunk Cloud stack. And so, and the only reason we do that is because our team, we are IT and security focused. And so our security team needs to look into this other Splunk Cloud stack for security purposes. And so the only way so they do that for the enterprise security, search head more specifically anyways. And so it's a little bit of a unicorn on our environment. So it is possible to do peering. It is tricky to do peering, only because support needs, they have to do this weird trick for the password SIM key encryptions and whatnot, but it's possible if anyone ever needs to peer. If for some reason there's multiple cloud stacks that they need to peer across, you can do it because we do it. So I think with the environment we peer to, I think we actually peer to like 36 stacks. I think Skynet has like 36 stacks, and we peered all of them. It's not super awesome, but we do it. And then we also have over here, it's our DMC. So we have our own standalone search head. It runs in Docker. I'll talk more about it in a little bit, but we have our own little standalone environment, and we actually peer that environment over to our Splunk Cloud stack, not over to Skynet at all, but just to our Splunk Cloud stack as well. So that we can do monitoring on Splunk Cloud and the environment as a whole, more specifically, just to make sure things are going well. So we don't just rely on support monitoring or, if you do alerting in the environment itself, if it goes down, it's not going to tell you it's down because it can't tell you it's down, right? So we have a separate thing for that specifically. So that's essentially kind of where we are right now. So the use cases, I've kind of alluded to this a little. We are IT and security use case centric. We do have some other use cases like the web traffic trends. We do bring in data from like Splunk.com. And we have teams that look at web traffic a little bit, as well as there's some other random little use cases here and there that specific teams go and look at. But generally, I mentioned earlier, we're really getting into observability this year. So that's a big use case for us. And the security teams look at a lot of things on our stack. We're really big into the security use cases. And then our team specifically, though, as I mentioned earlier, we do a lot of data onboarding. And because we do a lot of data onboarding, there's some app dev in there as well, mainly add-ons specifically. But we have done a little bit of kind of app dev. We have some applications that we use for monitoring the environment and whatnot. And so that's more specifically our use cases is helping users and getting data in and monitoring the environment. So our kind of deployment strategy here is we have a few different things that we do. So for our automation, right now we're mostly using Ansible. And so our syslog and Docker and deployment servers and maybe a few other things that I didn't think about all run from Ansible. And they get their things from our repositories, whether it's from GitLab or Bitbucket. And they manage things like our applications that get deployed to the deployment server or sent through the deployment server. Or for Docker, Ansible will build and deploy the Docker images. I always get terminology wrong. And then for our syslog, right, they would manage our rule sets and our firewalls and maybe some other things. With Ansible too, though, we do a lot of things in there. We have a ton of playbooks in our Ansible stuff. So like we can patch the operating system with our Ansible for all of our managed hosts, and we can install and upgrade Splunk, and we can do all sorts of, we have so many playbooks in our Ansible stuff, which is really great. So with our DMC that I mentioned earlier, this might sound a little confusing. It says cron. Our DMC, it runs on Docker, and it runs through a cron schedule. So every day our DMC is refreshed from our repository. So it's only using the latest repo. So if you're making local changes, your local changes are going to get wiped out of the DMC. And we did that specifically so that if someone went in and was editing an alert, like changed the threshold or whatever, made a typo or did something they shouldn't have done because, whatever, we just want to make sure everything is proper in there and agreed upon by all the peer reviews. Now, that's not saying it doesn't have drawbacks, because you could be working on a dashboard, or you could be trying to write a new alert or even edit a current alert, and if it restarted, you're going to lose your work. So it's important that you try and bring any of your work over to like a working like notepad of some sort, right? But everyone on the team obviously knows that that's it restarts and when it restarts, so they know to expect a restart. But that is how we wanted to do it, because we were running into an issue where people were doing local changes, and like a ton of our alerts were having things added to them or removed from them. And we had to go back through and redo all of our alerts. And that was time consuming.
Yeah, that's a great approach. I was going to ask about that, like how do you deal with local changes? And I'm guessing for other teams, it might be done differently, but that makes a lot of sense, as everybody knows anything you do local is temporary unless you push it through to the repository.
Yeah, we think it works really well for us, and it's something I think some other teams on our Splunk Cloud environment have alluded to wanting something similar to this on their specific app. We on our Splunk Cloud environment, we call them workspaces. We've given teams applications for their team. We call them workspaces. So like. We have one on, and so it's called the Splunk workspace, but it's obviously just a Splunk app. But it's where teams can do dashboards, reports, etc. For their team. And so that way all their stuff is, saved there. They don't have to save it in search and reporting or something, right, and forget where they put it. And so, but other people might go in and mess with their stuff locally, and and it's not fun when someone messes with your. So it's a nice way for version control.
Yeah.
I know some people have brought up similar things that they would like that, and we can't do very much with automation on Splunk Cloud yet. I know there's some things that can be done with automation on Splunk, but it's not 100% of everything yet. And so we're kind of trying to think about how we can help alleviate those kind of local changes on certain things. But it always depends on what endpoints are available for automation. And so whenever new endpoints are released, we're like, okay, what can we do with this endpoint? But yeah, it'd be those local changes when people stomp on something you created. You're like, well, what was there? Because you forget. Even when you make your own change, I did it this morning. I edited an alert I created, and then I broke it. And I was like, well, what was it before? I forgot what it was. And then I had to search through audit logs to see what it was when it last ran. And it was a mess.
Yeah, I've seen a few mechanisms in one of the presentations that I forget if it's the last conf we had in person, the one before that, basically exporting the configuration of everything within the app just with the REST commands and saving it to a CSV file.
Yeah. There's also you can we do it somewhere, or we did do it. I don't think we do it anymore. We were collecting btool config. So we had an index that had it was called like Splunk _btool or something, and it had all of the comp files for all of the different btool comp files. So there's a way if you want to hit those REST endpoints for btool and stuff, and you can get all of those configurations that way too. But yeah, if you want to do a REST call and index those, because you can get for dashboards, you can get the whole UI from that REST endpoint. If you want to index those in whatever frequency for that. But yeah, there's ways to get around it if you want to keep that data like that too. We don't, like I said, we did do that for a while. For something, this was when we were on-prem, we were doing that, but we never deployed that strategy when we moved to cloud. That was something that never migrated over. I don't know why, it just never did. But yeah, and then we do for our Splunk Cloud stacks, we generally use self-service we use self-service and support. It depends on what's being done. So generally we use Splunk Cloud support for apps and configs that for Splunk-based apps and configs, we have to basically create a support ticket, or if anything goes wrong in our environment. So we added like I mentioned, we added two search heads to our search head cluster. I should have added that. I could have added that under here. We just did that this last week, and so support had to handle that actually, because we are admins, but we're not admins at the same time. So support added the search heads to our cluster. They've added indexers to our cluster. They actually handle the peering to Sky. So anytime we have to add or remove peers, they do that. So support does quite a bit for us. And then, but for the self-service, we do self-service for any of the custom apps and add-ons and configs. So like I mentioned, we have like our indexes.conf and we do authorize.conf because we do that in our own repository. We also have, when we do data onboarding, we might have like props.conf or whatever that needs to go for field extractions and whatnot. So we upload those ourselves. So any type of like custom TA that might need to go on, or custom app if we have an app, we do upload those ourselves. We do handle like permissions to like apps and stuff ourselves. But really we don't do that much. We do some troubleshooting, obviously. If we have to file a support ticket, we like to do some troubleshooting ourselves before we file the ticket so that we can help support along the way. But really a lot of stuff is handled by support in Splunk Cloud because that's what they're there for. So that's really kind of our deployment strategy is we're trying to do as much that as we can with automation. But otherwise a lot of stuff is done through cloud support if it's in Splunk Cloud, making our life as easy as possible when we can.
Yeah.
We do, as I mentioned, I've talked about our DMC like 100 times, so I'm going to talk about it a little bit more. So we do monitor our environment. Obviously, it's really important to us to make sure we have availability, not just with the environment, but also with the data and with everything that goes with it, right? So we obviously, we're on call because we control a system that is heavily relied on, especially with security, which is super important. So we started having like an on-call weekly meeting. And when we started these on-call weekly meetings, we went through very thoroughly the alerts that came in, what happened during those alerts, how can we improve either the alerts, were they false positives? If they were false positives, how do we improve the alerts? If they weren't false positives, we need to do the root cause analysis, and we need to make sure we, can fix them for future reference so they don't keep happening, things like that. So we have brought down the number of alerts that have fired drastically, except we did just make a change recently that originally, so we do track data outages, possible data outages. I should be more specific. We don't know 100% that they're an outage. So we alert on those. And originally with our Victor Ops or Splunk on Call, I need to be more specific, the name changed. With Splunk on Call, we were only alerting, the Splunk on Call would alert us when something went into outage, a piece of data went into outage. And then the way it would work was that any other index that might have gone into outage would just go under the same incident. And we found a way, this should have been clear to me earlier and it wasn't, we found a way to send a new alert for any index that was in outage. So you could keep that acknowledged and then it would send a new alert for every index. So now it's spiked again. The numbers of alerts have spiked for possible index outages, but that's okay. It's okay. Like I mentioned, our DMC, it runs on Docker. It's not technically in our swarm. It's its own like little standalone Docker container that has version control and only uses the most recent version in the repository. So if something happens and we're like, oh, we fixed this outage or whatever, or we did something, we have to make a change. It won't actually take effect until the containers restarted after the merge request is merged, but that's okay. We just have to deal with it. But we use on our DMC, we use lookups for everything. So we have lookups for hosts that we monitor. and data that we monitor. And like we monitor for indexes and sources and source types and hosts, but we also monitor for things like our index queues, and we monitor for searches that run too long or even high volume searches, and like exec processor errors. And I'm trying to think, TCP processors being paused, things like that. So we monitor, I think we have like well over 100 alerts on our DMC that we monitor for. So it's hard to remember all of them. There's a ton. So we do quite a bit of monitoring, but it's definitely helped our environment stay fresh. We also do a bit of CI/CD. We're really ramping that up this year, starting I think last quarter into this year, where we're starting to do more. Is mainly through Terraform and Ansible. So Terraform, SignalFX is really big with Terraform. A lot of SignalFX uses Terraform, and SignalFX is obviously observability, which is we're really getting into. So we really need to start using that. And so we've deployed a bit of SignalFX via Terraform, but we're obviously developing more because we're getting more into that observability space this year. But with Splunk, we are developing quite a bit of CI/CD via Terraform. It's in the works right now. So for instance, we're trying to create some automation for our Splunk Cloud to automate RBAC in a way to create or update roles for Splunk Cloud. So that way we don't have to do it in Bitbucket and then upload the app and then deploy it, right? We can do it all through Terraform. And same thing with our indexes.conf. And I think we're working on a way to do update our lookups as well. So we're working on those. And then we do a lot with Ansible. So I have a link in the references for a lot of the stuff we do with Ansible. I kind of mentioned a few earlier. And it's the same thing with, like I mentioned, we like patch our OSs and do a handful of our OS management. But we do a lot of stuff with Ansible. So what is next for our team? We're going to be migrating to ECS from Docker at some point soon-ish. And that's mostly because we're trying to move out of our data center. We have a handful of those servers that live in our data center, and we just kind of want to move everything over into AWS. And then we need to start incorporating everything into Vault. And that'll really help us with our automation as well, if anyone's familiar with Vault. And I think we started that process a little bit last year, but it got kind of put on the back burner. And then obviously I've mentioned this like 1,000 times, observability. And so obviously we'll manage those configurations with Terraform, and we'll do a lot of stuff with SignalFX this year. And then I'm not sure if we'll be using anything else, but it'll probably mostly be our SignalFX stuff. This is the resources I have. The first 3 links are some of the open source projects our team has created. So the first one is the Ansible role that we have. This is what our team actually uses, Ansible role for our automation. It's not 100% what our team has, because our team obviously has customized it for our environment. So it's kind of like a bare bones Ansible role, but it has a lot of the playbooks that we use. And then our Vault sync, like I mentioned, we kind of started in on Vault. We just haven't deployed everything yet. And then our Docker Swarm stuff, because we do use Docker Swarm. And then I just put a lot of links in there about, so the observability stuff, and then some Terraform, Ansible, and some other documentation, as well as a link to my blog post, because why not just put that out there too. So this is all I have. If there are any questions before we wrap up.
Yeah, I'll put those links in the description of the video once that's uploaded, so people can get to them easier.
Yeah.
So you're moving everything to AWS Cloud, except of course the DMC is going to have to go to a different cloud provider or something.
Our DMC will likely go up to AWS as well.
Okay, so as long as AWS is going to report
Yeah,
its own
I'm not, we don't have like a set game plan of how or when or what exactly everything's going to move to. It's just kind of a rough, we want to move everything off of the data center and it'll likely go over there. But that's all I know right now.
I'm just joking. It's about how paranoid you are. How many different things do you want in the loop so they can watch each other?
Right.
Very cool. Does anybody else have any questions? You know, people must have been booked during this lunch. We got slightly lower than the usual, but those who missed will catch up, and I'll speak for myself. I thoroughly enjoyed this presentation. I'll be going to the user group leader channel and saying, "Hey, bug Clara. She gave a really awesome presentation," and then you might hear from others.
Okay.
Be warned.
Very good, Clara.
Yeah.
Did you give her a few days to unpack her boxes first, Angie?
Yeah, there are quite a few boxes here. I haven't hardly done anything. I literally just got my boxes yesterday, so there's nothing unpacked yet.
Where'd you move from to?
I was in the Bay Area in California, and I moved to Colorado.
Okay.
So it wasn't cross country, but it was far enough.
Awesome. Well, if there are no other questions or no other user group things that people want to discuss or ask, then we can wrap it up here. Thank you, Clara.
Yeah, no problem.
And thank you for pulling it together. I know this did not exist before we asked, so.
Yeah, it wasn't too bad. I just didn't have time to rehearse anything, so I kind of winged that. But it's all right.
Out rather well.
Yeah, it was. We're your beta audience.
Yeah.
Right,
thanks.
Just drop me. Oh, sorry.
I was going to say, just thanks for sticking with me.
Yeah, drop me those links through Slack, probably easiest, or just drop them into a Zoom chat, and I don't want to be retyping them.
Yeah, no problem. I can do that.
All right. Thanks. Bye, everyone.
Thank you.
Bye.
See you
Bye.
next
Thanks a
month.
lot.